We are in week 4. We will talk about Module 4. We will introduce the last template array class. This week, we will implement dynamic array. So dynamic array also is a template class. So what is dynamic array? For the array class, we implement last week for the static array. So that static array, you only have one capacity. The cap should be a constant number. Once you define, when you create an object, they already be defined. The cap actually cannot be changed. But now the dynamic array, actually we will have a capacity is a variable capacity. So that means if user needs, we can resize our capacity. So that capacity can be enlarged or shrink. So in order to make that happen, this week when we implement our dynamic array, we also need to use the dynamic memory. So that's what we will talk about how to implement the dynamic array. But before that, I want to talk about more in detail about what is the data abstraction. Sometimes we heard about data abstraction. So what is the data abstraction? The data abstraction actually is what we have in the template class. Before in assignment 1, did you remember in assignment 1 when we have the operator, no matter getter function or setter function, we only need to return the 0. And we return this 0, that's because our return type is int. That's the limitation for our assignment. Oh, we are in assignment 2. Yeah, this one actually came from assignment 2 and 3. So in assignment 2, when we have our array class, we only have the int data type. But then we figure out actually our array class can be any data type. So that's why we introduce the template class. So the template class, we will specify the template keyword. So then you can have the type name using any variable name you want. For this example, we're using the t. So this t actually can replace with any data type, right? Because our array can be integer, can be double, can be string, can be any data type, any object user defined. So that's why when we want to return a t object, so then here we cannot return 0 because the data type is different. So the easier way, we just return the t parentheses. So to be more detailed, to talk about what is the t parentheses, the t parentheses actually is called the default constructor for the object we will return. Because one thing is, we have the int, double, string, but our array can also store any user-defined object. So then here we're using a t parentheses that we can know any object we return, we will return using the default constructor to return. So most of you actually from your lab exercise 3, you did very correctly about the implementation for our static array. But one thing I want to show you is here, because I saw few of you actually got your default constructor wrong. Okay, so here I want you guys to see here, no matter you got that correct or wrong, I want you to see both here to see anything wrong for the code here, for the default constructor. Okay, you see what's wrong with this default constructor? I'm not sure why some of you make this one incorrect. Because one thing is, we say we need to initialize every element, right? But every element is not dummy, okay? So actually here, I'm not sure why a few of you got this wrong. So this one, unless you already define dummy equal to t parentheses, then you assign equal to dummy is okay. But one thing is, in your default constructor, your value is not initialize all the value to dummy. This comment is wrong. It's not our purpose. Our purpose is initialize all the elements equal to the default value. Just also dummy also equal to the default value. Okay, so be careful I think few of you got this one wrong. I'm not sure is I have incorrect note for you guys or something wrong you missing understand. Okay, so that's be careful about your assignment 3. So that's why here is be careful. The default constructor we try to use before in assignment 2 is because we only have int array. But now our array can be any data type. So that's why we initialize in the constructor. We make the each element equal to the v parentheses. Or if your type name is t, use the t parentheses. And also this v parentheses, like I say, because we don't know the v data type. So that's why if that's a programmer defined struct or class, we call the default constructor to assign the default value. So because you see this one, we have the equal sign, right? So before, if you try to assign the 0 to the element, then because that's the primitive data type, we will assign by copy. However, here, if you try to assign an object, then we need to be careful to know is this object is a static object or the dynamic object. So that's why here, sometimes in the user-defined class or struct, we may need to overwrite the assignment operator function in the user-defined class. So to write the assignment operator function, actually they are the assignment operator overloaded function. For example, if for the string class, this assignment operator function will be look like this. Remember our assignment operator function, we always have the operator. Then since here our operator is equal sign, so we put the equal sign. So this one here I highlight operator equal sign is the overloaded operator function name. So then the parameter will be the object you want to assign. So then remember we need to assign to from the left hand side, right? So then you will be another object reference for the assignment operator. So this one we will talk about more detail in the future class. If user try to using the v is the user defined to using our array. So then we need to be careful to see do we need to overwrite the assignment operator function or not. Okay, so that's the data abstraction and also some review before our module 4. So now here in our module 4, we really need to start talking about how to make our array capacity is a flexible size. So that's why you see before in our static array template, we have our static array, then we have the data type. So since here, then let me write the state. We make the array name actually is the static array. So then one thing is we need to be careful. Actually, for you define an int array, the capacity is 10. If you give them the constant number, this one is the valid symbol. Okay. However, if you try to pass in the capacity, you make a variable. Actually, this one is not valid. So why is not valid? Because actually when we define our cap, okay, so did you remember in your implementation, you have your t in the parameter list, you have a values, then you're using the square bracket for the cap. Right, so that's why here, be careful, we told you before, right? This one is the C array. So the C array, when you define the C array size, we need to be the constant number. So that's why if you try to using the static array, then you try to give them this capacity size using a variable. Actually, that will be invalid. But now actually in our dynamic array, we do want to make the user can specify their capacity size. So how to pass a variable of the capacity size for the array. So this one actually we cannot using the angle bracket, because the angle bracket actually is for our type name and the int cap we define. So in order to available to passing a variable name through the constructor, so that's why here actually in order to pass a variable to our array definition, then here actually we will see, for example, did you remember in 165 when we learned the vector? Your vector, the same thing, you have angle bracket to specify the data type, but the capacity size we're using the parentheses. So did you notice actually this parenthesis mean what? So this parenthesis actually we call the constructor function, right? So if you want to allow user to pass in the variable capacity size, then we need to using our similar like our vector implementation. But this week we will do the dynamic array. So this dynamic array, our cap is no longer in the angle bracket. Our cap actually will be passed in the constructor function. So actually that's our library will look like. So on the other hand, like I say, actually our cap will no longer in the angle bracket. Actually our cap will be in our constructor function. So now before our constructor function, remember we only have the array parentheses, we passing nothing. So now in our dynamic array, our constructor function, we will change become the parentheses passing the variable. So since here we're using the variable name, so now here the int, the cap, that's changed to the lowercase cap. So we want to be distinguished from our assignment 3, our static array. Remember before our static array we have is the capital CAP. So this capital CAP in the angle bracket should be a constant number. But now here we will become no capacity in the angle bracket. Instead, they will be in the default, will be the constructor. It's not default constructor, it's a constructor function. So that's why here that's changed a little bit. So this one on the left, remember that's from our static array from last week. Last week we have this template static array, but we have our type name v here. Then we have our int cap uppercase is constant number in the angle bracket. So then we create a static array. So then we have the cap in the square bracket. But now this week, when we write our dynamic array, we will become like this. Our dynamic array will become template, still the same. But in the angle bracket, we only have type name v. So then here you will see the first thing we will, instead to create a static array, we only have the v pointer values. So this v pointer's value actually is our dynamic memory. So later I will show you we will new the array in our constructor. But before that, we need to have a second parameter. So this second parameter is an int cap. Okay, because capacity always int. So that's why we have int cap. So then of course we need to have our constructor function. So then let me show you. So let's start working on our lab exercise, our header file. Okay, so then you have if not defined dynamic array, because we will create our array class actually called dynamic array. So if not defined, we define. Okay, so don't forget at the end, of course, we need to have the end if. So now here you will have your template to type name T. So the array class name is dynamic array. So then here you will have the T pointer for the values array. So then you have the int cap. So then our dynamic array constructor function will have the int data type for the parameter.